Hello everyone, my name is Vedant Jarke and my roll number is 87. Today I am going to present an analytical instrument, opacity meter. This instrument plays an essential role in many industries from monitoring environmental emission to ensuring the quality of products. In the next 15 minutes, I will explain how it works, what is it made up of, and why it's so important. Let's get started. Opacity meters are essential analytical equipments used across various industries to measure the degree of opaqueness or cloudiness in a given material or substance. These versatile devices play a crucial role in quality control, process optimization, and environmental monitoring, providing valuable insights into the physical properties of a wide range of materials. Let's begin with a basic question. What is opacity? Opacity measures how much a material stops light from passing through it. Something completely clear like glass has low opacity. Something like smoke or thick paint has high opacity. An opacity meter helps us measure this property. It tells us exactly how much light is being blocked, which is useful in many industries like paper making, wastewater treatment, and environmental monitoring. By using this device, we can ensure quality, follow regulations, and make better decisions. Opacity meters have come a long way. In the early days, people used simple methods like comparing material to a chart to judge their opacity, but this wasn't very accurate. Later, scientists developed photoelectric opacity meter that used light sensors to measure how much light passed through a sample. These were much more precise. Today, modern opacity meters have digital displays, can store data, and even connect to computers. This evolution has made them very reliable and widely used in the industries. Further developments include the integration of microprocessors and computer interface, allowing for enhanced data analysis and reporting capabilities. Modern opacity meter offer a wide range of features including different measurement modes, data storage options, and connectivity of integration with other laboratory equipment. This continuous evolution has made opacity meters indispensable tools in various industries, contributing to improved quality control, process optimization, and scientific research. Opacity meters work based on a simple idea. A light beam is shown on the material. The light interacts with the material, some of it gets blocked and the rest pass through it. A sensor measures how much light come out on the other side. By comparing the light that went in the light that came out, the meter calculate the opacity percentage. For example, if only 20% of light come through, the material has 80% opacity. This is the basic principle that all opacity meters follows. Now let's look at what an opacity meter is made up of. Uh, Opacity meter is made up of four different things: light source, sample chamber, light detector, and display screen. Let's talk about the types of opacity meter. These are three main types of opacity meters: benchtop opacity meter, portable meters, online meters. In benchtop, these are large and stationary. They are used in laboratories where precision is very important. In portable meters, these are handheld devices that can be taken to different location. They are slightly less precise but very convenient for field work. In online meters, these are built directly into machines on production lines. They monitor materials continuously and help make real-time adjustments. Each type is designed for specific needs. Let's talk about the key components and functionality. In light source, this is usually a small LED or laser that produces a steady beam of light. In sample chamber, this is where you place the material you want to test. It's designed to make sure outside light doesn't interfere. Light detector. This measures how much light passes through the sample. And fourth one is display screen. Finally, the results are shown on a screen or sent to a computer. These parts work together to provide accurate measurement of opacity. Let's talk about the applications and use cases. Opacity meters are useful in many industries. Here are some examples. In paper manufacturing, they check the opacity of paper, which affects its quality. In wastewater treatment, they measure how cloudy water is, helping to keep it clean and meet environmental rules. In pharmaceutical industries, they check the clarity of medicines to ensure they are pure and safe. And fourth one is environmental monitoring. They measure pollution in air and water to protect the environment. These devices are incredibly versatile and valuable. Let's talk about the study case studies. It includes paper manufacturing, wastewater treatment, pharmaceutical production, environmental monitoring, and industrial processes. Calibration and maintenance. To keep an opacity meter working properly, we need to maintain and calibrate it regularly. Calibration. This means testing the meter with materials that have known opacity values. If the readings are off, we adjust the meter. Maintenance. This involves cleaning the sample chamber, checking the light source, and ensuring the detector is working well. These steps ensure the meter stays accurate and lasts a long time. Let's talk about the data interpretation and analysis. When we measure opacity, we usually categorize it into three ranges: 0 to 20% opacity, 20 to 80% opacity, and 80 to 100% opacity. In the 0 to 20% opacity, this means the material is mostly transparent. In the 20 to 80% opacity, this means some light is get blocked and the material is partially opaque. In the 80 to 100% opacity, this means the material blocks most of the light and is almost completely opaque. By analyzing this data, industries can improve their processes and make better products. Now, let's talk about the conclusion and future development. Opacity meters are becoming even better thanks to new technologies. Some meters now connect to the internet, allowing us to monitor data remotely. Others are artificial intelligence to predict problems before they happen. These advancements will make opacity meters more accurate, faster, and easier to use. In the future, they could be used in new areas like renewable energy and advanced material research. Thank you.